Dr. Dan.
Good afternoon. How we doing?
After lots of hours and a lot of scratch paper, I've finally almost finished all that physics homework. Jesus.
Keep pushing, man. Got a week left.
Got one more to do. One more. God is good. I didn't think I was gonna get it done.
Well, hopefully everyone else has the same go get 'em attitude, right?
Right. I hope so.
All right, so we'll let everybody trickle in here. Just gonna go over a few things.
Hello.
Hi.
Danger. What's up, Doc Dean?
Just trying to get all the paperwork done.
Oh, that's right.
This online format has us doing a lot more extra stuff that I was not prepared mentally and emotionally for, so trying to plow through it. Let's see. Okay. So as y'all know, we have a test that is currently up on Cengage. As in the past, there are 3 attempts. You do not have to do all of them, but I would recommend doing the first one at least pretty soon, not waiting until, Saturday night to do it, or especially not waiting until Sunday night to do it, because they will close on Saturday night at 11:59. So 11:59 on Saturday. What days do they close? What day does it close?
11:59 Saturday.
On Saturday, that's right.
Test 4 or the final?
I'm sorry?
Is that test 4 or the final?
That's test number 4. So the final, some things are going to be a little bit different with that. So we're going to be reviewing the rest of the week, basically, for that. But I'm going to be opening it by Wednesday, probably tomorrow, because I've got some seniors speckled throughout my classes, so I'm trying to get all of them up at the same time. So as per the administration, senior finals, let's see, where's the email? So senior finals technically need to be done this week, but I am, because of the format that I'm doing, I will probably have the final open through Sunday evening, because senior final grades are due Monday. So that will allow me to wake up early, get those downloaded and entered, and have them turned in, so that you guys have as much time as I can give you. Yeah. So for non-final or for non-seniors or non-graduating seniors, because you're not graduating and your grades don't have to be in early, the due date for that will probably be next Wednesday, because I think that's when your final was supposed to have been taken. So just remember, if you are a senior, everything's got to be in by Sunday night. And so the due date for all the homeworks and stuff is already on Sunday night. But when the final exam gets posted, you've got to do it by Sunday night. If you're a senior, I will send out multiple emails about all of that. But yeah, keep that in mind, that if you're a senior, everything's got to be in by Sunday. Let's see. All good questions. Okay. What else? Who else has a question, comment, concern?
I don't understand what you put in the Discord
Okay.
for that problem. I really
right.
don't understand.
Okay. There were two questions in there. Let's see. I don't want that. I want. Okay. Sorry, your thing is sideways. I don't think this is going to let me change it. Okay. So figure shows path of a beam of light through several layers with different indices of refraction. What is the angle number 2? And what is the smallest incident angle, theta 1, to have total internal reflection at the surface between the medium? All right. So is that the one you're asking about, or is it the second picture?
The first one. Can you hear me? Okay, cool.
Yeah.
The first one, and then number 9. No, yeah, the first one, number 9. Is that 9? Yeah, 9.
Number 9 on homework 22.
I believe it's 20. Yeah.
Sorry, I'm trying to. Okay. So number 9, I guess, is simpler. So we can look at that. A beam of light is incident from air on the surface of a liquid. The angle of incidence is something. The angle of refraction is 22 degrees. Find the critical angle for the liquid when surrounded by air. Okay. So what, I guess, do you mean, what don't you like about that, or? So the critical angle is the angle at which the light can't refract. Okay, let's see.
Okay, but
sorry, I'm trying to pull it up. So you have something that looks like this. Okay, so this is our interface, and just for my problem, you have a ray of light coming in, and this angle is 38.5 degrees, and then the angle of refraction (22.2 degrees). Okay, so find the critical angle for the liquid when surrounded by air. So this is from the other side. Well, I guess the first thing you do is you need to find the N value. So we have N of air. What is the N value for air?
is it 1.333 some?
I thought it was 1. Pretty sure it's 1. Make me question myself. So air is technically it's 1.0003. But yeah, for our cases, it's just 1. So what we need to find is N equals, what is the N of this liquid? So what do we use to find the N of that liquid? What relationship do we use? This should be like, it's like,
Is it cross?
no.
Please don't be all sweaty.
So N1 is 1, sine theta 1 is sine 38.5, N2 sine of 22.2. So N2 38.5 sine 22.2. And that gives me 1.647. That should be close enough for the rounding. Okay, so the end value of this is 1.647. So the critical angle is the angle where if light tries to go the other way, it's going to get pushed out. Show you what I mean. Now that we have that. So if light goes the other way, where's a different color? So when it went this way from air to water, it got bent inward because it slowed down. So the critical angle is, because this is going to get bent outward, it's going to bend so far that it doesn't actually leave the water. It gets bent straight down the edge. This is what we call total internal reflection. But what is that angle?
90 degrees.
90 degrees. So we have our same equation. In air sine theta air equals in liquid sine theta liquid. Well, the end value of the air is still 1, so that just goes away. The end value of the liquid is 1.647. So what is the angle of refraction in the air?
90.
90.
Right.
Exactly. And what is the sine of 90?
1.
I'm sorry?
1.
Perfect. So 1.647. So you get, first you divide this over, and then you take the inverse sine. So you get of,
Is that a 6 or a 5 that you have?
I'm sorry?
Is that a 6 or a 5? 1.5 or 1.6?
6.
1.647.
Okay.
So it's kind of 1.65. So I get 30. Three, 9. So the critical angle thing is a very, it's the same, it's that same equation, but it's a very specific kind of case. It's when the outgoing angle is 90. And critical angle problems are very simple because of that fact. And so if you kind of took it back, you could say the critical angle is always sine of in 2 over in, I'm sorry, sine to the negative 1 of that. So if you want to use that equation for those, then you can use that. But because sine of 90 is always 1, it simplifies that out. Now, it is kind of important that this is only true. Well, let's see if we can figure out. What has to be true in order for this to work? The thing inside here, what has to be true about it?
Does it have something to do with the angle?
Kind of. But what's the biggest? Let's look at sine of x. What is the biggest thing that you could get out of here? I'm sorry?
1.
1. What's the smallest thing that you could get out of there?
0.
It's not 0.
Negative 1.
There you go.
Negative 1?
Yeah, negative 1. So inverse functions work backwards. The biggest thing that you can put into the inverse function is 1. The smallest thing you can put in is negative 1. So this can never be bigger than 1, or it'll never be negative in this case, because we'd be getting into some science fiction type stuff there. But it would require like time to go backwards and pretty random stuff. But the point is, if this thing has to be smaller than 1, then what is true?
There's no factor bigger or greater than 1. Everything is less than 1.
So if this is less than 1, then the n value that the ray starts in has to be bigger than the n value that it's trying to go to. So this is why it doesn't work in both directions. So if you're going from the air to water, because this n value is smaller than this one, then this never happens. Okay? Because the one that you start with, which is N1, has to be bigger than the one you end with. But if you go the other way, this does work. So if the ray goes over here and comes up this way, then this can happen where it refracts and goes at 90 degrees. Okay, so the idea is with a critical angle, oh, where's my green? So it's 37 point something. The idea is if you have any light that's coming from over here and it comes up and hits, what's going to happen?
It's gonna go back down, right?
Yeah, it's only going to hit and go down. None of it will ever hit and go out because the angle of refraction going this way bends out. But it can't bend further out than this way. It would only come back here. So if you came even further, then you would only have it come back in. So that's the point of the critical angle. But finding it is pretty simple. It's just that thing. Good question. Okay. So for your other one is just this first process that we did applied over and over. Okay. So I'll kind of draw a recreation of it. So it says that light comes in at some initial angle and it comes in, actually draw it a little bit different. And so at every point it hits and gets refracted. What it wants to know is what angle does it come out at? So it gives you this angle and it wants to know this angle. So how do we figure this out?
Do the same thing we did with the other one, right? N2 over whatever angle that is at the bottom, right?
Yeah.
Which,
So first thing you do is you find this angle, and that angle is going to be sine -1 of if you take that normal equation, N1 sine θ1 into then sine θ2 is N1 over into sine of θ1. But now this theta gets used right here. So theta 3 gets a very similar treatment. In 2 over in 3. Theta 3, or I'm sorry, theta 4 is the same way. But we kind of see maybe a pattern. The next time, we always end up using the sine of the angle we just found. So I have a question. What is the sine of sine -1 of theta? So this should be something that I know at minimum you should have learned in Math 111. What is the
Say the question again.
What is the value? It's not a number I'm looking for, but what is the sine of the inverse sine of an angle?
Mhm.
It's cosine, right?
I'm sorry?
Cosine, right?
It's not cosine. What does it mean to be, for a function to be an inverse of something?
Opposite 10.
Kind of. It is a kind of an opposite. So a function, back to our Math 111 days, f of x, let's say it's, I don't know, 5x plus 3. A function takes an input, in this case x, it does some stuff to it, and it spits it back out.
X equals 3 over
Something.
5.
I'm sorry?
X equals 3 over 5. Well, what's the value of x? In order for you to do
No,
that, you have
so
to have a
that's,
value
this
of
isn't
x.
f times x. This is
Okay,
f
cool.
of x.
Gotcha.
So if you had f of 2, this would be 5 times 2 plus 3. So the
13.
Yeah, a function takes some input and gives you something out. Well, the inverse of that function should take the thing that came out and give you back what you started. So f
So
of
would it
x
just
equals
be
that. So if f of 2 equals 13, then the inverse of x of 13 will give you back 2. So this transforms 2 into 13. The inverse, by definition, transforms 13 into 2. So f of f to the -1 of x equals what? Let's say,
I can't read that. Not even allowed
how
to.
about
-2, right? Well, -13.
so Maybe we should do this. What is the inverse of f of 13? We said that the inverse of f of 13
F
is
of
2.
So f of 2.
But what is f of 2?
13.
If you apply a function and its inverse, you get back to where you started every time, assuming the functions aren't like dealing with infinites and dividing by zeros, anything weird like that. So if you apply a function and then its inverse, you get back to where you started. If you apply a function and its inverse, what do you get?
The inverse in its function?
I'm sorry?
The inverse in its function?
Over here, we applied a function and its inverse on a number. What did we get out at the end?
The number.
The number. The thing that we put in,
So you get theta out of that then?
you get theta.
I should have said that.
So if you apply that and up to here, what is, if this is theta 2, sine of theta 2 is just everything inside it. So sine of theta 2 is actually n1 over n2 sine theta 1. Right? Well, that means theta 3 actually equals sine negative 1 n2 over n3 n1 over n2 sine theta 1. But theta 4 then is sine negative 1 in 3 over n4 in 2 over n3 in 1 over n2 . So, but what is this? N3 over n4 times n2 over n3 times n1 over n2. What does this equal?
Theta 4. Okay.
Not quite.
Sine beta.